So this problem is for the heating curve for benzene, C6H6. It is identical to the steps that we would do for water. We're going to still draw out diagonal, flat, diagonal, flat, diagonal. Okay, we're still going to call it line segment A, B, C, D, and E. This is not to scale. So it doesn't matter if the steepness is not what it would be in real life or the length of the phase change is not to scale. None of it's to scale. So it's just to make sure that you are walking the path correctly. The diagonals are still Q equals MC delta T. The flats are still Q equals N delta H. Okay. But now our C value for segment A is going to be 1.04 joules per gram degree C. Oops, sorry. We don't have a C value for down there. We have just a C value for the liquid on your table, 1.74 joules per gram degree C, and a C value for the gas of 1.04 joules per gram degree C. So make sure you're looking off of that and that you have the right spot. Notice how I looked at the top C value and assumed it was a solid, but it's not, it's the liquid. They did not give you the specific heat of the solid of benzene because you won't be seeing that. Okay. It gave us the melting point, okay? So that would be right here, 5.48. And it gave us the boiling point. That would be your next flat line. And that would be at 80.1. So I'm laying this out exactly how I laid out the water one. It's just going to have different standards because it has different melting and boiling points. It has different specific heats. And it has different heats of fusion, which would be 9.90 kilojoules per mole. And it has different heat of vaporization, which would be 30.77 kilojoules per mole. So now I have all the data here on any benzene. So I can get any number of moles of benzene, any grams of benzene, any starting and ending point. I have the gist here of what I'm going to need. So what do I have? I have 6.7 grams of liquid benzene, which I can convert to moles. Okay, I have how many moles? So let's see. We have 6 carbons at 12.01 each, and I have 6 hydrogens at 1.01. So my total molar mass of benzene is 78.12 grams per mole. Okay, so I need grams on the bottom because we started with grams. 78.12 grams in 1 mole. So 6.7 divided by 78.12. It's going to give us 0.0857. Only need 2 sig figs of that, 0.086 moles, okay, of C6H6. So now I have the grams and the moles, so I have it for when I need grams and when I need moles. I'm starting at 12 degrees C. Okay, so on this chart, 12 degrees C is on line segment C. Double check where your positions are. 12 degrees. Warmer than when it's a solid, colder than when it's a gas, and I can arbitrarily put it anywhere on here because remember, we're not going to scale. And that would be my temperature initial of 12 degrees C. To gaseous benzene, okay, well that's telling us right now it's going to have to be on line segment E at 100 degrees C. And does that make sense? Yes, because it's going to boil at 80. So at 100, it's going to be in its gas state, and that would be my temperature final. Okay, so how many line segments do we need on this one? Only C, D, and E. My Q total, which they want in kilojoules, is just going to be Q of C plus Q of D plus Q of E. So this problem's going to go a little bit faster. QC on the diagonal, MC delta T. Okay, 6.7 grams. What's the C for that one? Written right there, 1.74 joules per gram degrees C. Delta T, temperature final. What is the temperature final of just line segment C? Oh, it's at its boiling point, 80.1 degrees C, minus its temperature initial, where we started, 12 degrees C. All right, so what is that Q? Okay, 6.7 times 1.74 times the quantity of 80.1 minus 12. That gives me 793.9. What units is that? Joules. Okay, so I'm not done yet because my answer is going to be in kilojoules. Oh, and how many sig figs? 2 sig figs, so I'm going to do both of that right there. 0.79 kilojoules. My Q, so this is line segment C. My line segment D is on the flat, so I use N delta H. My number of moles, 0.086 moles. My delta H is the heat of vaporization, 30.77. So I'm left with kilojoules, so let's see how many kilojoules. 0.086 times 30.77. 2 sig figs only, 2.6 kilojoules. It's all the heat for step D. Now we're on step E, which is a diagonal, so I'm going to use the MCAT equation. My mass, 6.7 grams. My C, 1.04 joules per gram degrees C. Delta T, well, my final temperature is the official final temperature of 100. Minus where that line segment started. That line segment started here, which is at 80.1. And that's going to give me an answer in joules. Okay, so 6.7 times 1.04 times the quantity of 100 minus 80.1. That's going to give me 138.7 joules. I have to divide that into kilojoules. 0.14 kilojoules, because I only need 2 sig figs. My Q total, QC, 0.79, plus QD, 2.6, plus QE, 1.14. And that gives me 3.5 kilojoules for the whole path.